All right, welcome everybody. This is Kubernetes SIG Instrumentation. Today is January the 23rd, and we have today's entire session dedicated to an introduction to cloud events. And we have Mark here giving us that introduction. So without further ado, Mark, take it away.
Thank you. I'm Mark Peak. I'm a principal engineer at VMware, and I've been working with serverless for quite some time. Helped kick off the serverless working group back in mid-2017, and then part of the rationale behind that was, while public clouds had serverless offerings, there wasn't really a good understanding about what does that mean for non-public clouds. And so what we wanted to do was get together a bunch of industry people to talk about, what is the technology, the ecosystem, and what should the CNCF have an opinion on about serverless. And so we released a white paper in 2018 to, be able to give that take on it, and also to develop the landscape of what are the companies that are actually delivering different portions of that ecosystem. And so all of that stuff's online. After we finished that, we had a lot of next steps in our white paper. And so we decided that, what was the most important thing to go after? We felt that having some level of common eventing, and by common eventing, I don't mean that every event has to be identical across clouds, but just a way to better identify what the event is and how to transit that event. And so we kicked off this effort called Cloud Events. It was part of the serverless working group, but then we applied for that to be a CNCF project itself. And it has now made it to incubation stage as of late last year. We also, based on the work that we did, have created a version 1.0 of the specification for cloud events, which was released along the same lines. Just one second. All right, so what problem are we trying to solve with cloud events? We live in a multi-cloud and multi-service world. I know that I interact with multiple public clouds. Being from VMware, I interoperate with private clouds, SaaS services, et cetera. And it's not always clear how you can do eventing across between these clouds. I might want to stitch together events coming from a SaaS service going into my public cloud. How do I identify what that is and be able to handle that correctly? And so really what we're looking at is, how do you transit the actual payload of the event without changing it through different types of routing? And so we really wanted to have this way to attach metadata to events for that transit. If you look at what events are, and this is probably well known to all of you, there's some occurrence that happens, and it's a statement of fact about something that did happen. The event is expressing that occurrence in the context. So now that we have this event, we need to now deliver it someplace, and then some action will be taken. It could be, sent to dev null. It could be acted upon with a functions as a service. It could trigger other types of automation, or it could just go into a log somewhere. So there's a variety of different ways that you can now act upon or do something based off of that event. So when we look at a more complex system where you might have something occurring out in the cloud, you have applications, you might have the function workflows. All of those things could be interoperating with each other, and you need some way to express what that is. And so we've broken that down into what are the messaging protocols for me to be able to talk between those systems. We then also have HTTP endpoints that we need to be able to deal with. There's unified event context where you may want to do filtering or routing or subscription management within some of these endpoints based on what that event is. Common usage nowadays is having webhook endpoints in order to facilitate that event delivery. We have, as I mentioned, one of the things that kicked this off was all around how do you deal with functions and the events needed for those functions. And so we wanted to be able to better specify how, what is the format of the event coming into those systems, and how do I identify what the type of that event is such that I can route it correctly to the correct function. And then we have a variety of different needs around SDKs. One size SDK doesn't fit all, and we need to be able to have the appropriate language bindings to make it easier for people to interoperate with these cloud events. Here's another diagram talking about the complexity that we're trying to help mitigate, where you might have IoT devices that are sending to an IoT gateway. That's likely going to be going over MQTT. How do you get that event bundled into MQTT in order to now deliver it to that gateway? That gateway can now use a variety of different formats to deliver it to other systems, things like NATS, Kafka, HTTP, AMQP. And then from there, those systems are likely intermediates. So they will now need to send those on for additional processing through Cloud Stream Analytics or data lakes or some other type, functions as a service as well. And so the bottom line here is that cloud events is trying to define this common metadata around the events. We understood that we need to make it simple enough but expressive enough to be able to deal with different formats and transports to be able to move that event through systems and then be able to act upon it when it finally gets delivered to the consumer. And so we've tried to develop both the specification and the SDKs to facilitate this. So if we look at, what is this thing? If we just look at HTTP, this is a typical HTTP header and data that's being sent, a payload that's being sent along with it. Happens to be application JSON. And we thought about this and went, how can we make it easy to adopt cloud events by just adding a certain number of required fields, specifying what the specification version is so that we can now be able to decode the other fields correctly. What is the type of this event? And this is a new item and it's coming from bigco.com. This is one way to be able to have a designation of that type. We want to be able to say, what's the source? Where did it come from? And then what is the ID on this? Those are the 4 required fields in order to transit a cloud event through the various systems. Now, based on this information, I can now reason about it by saying, oh, this is a new item. If I deliver it into a functions as a service, it knows where it's coming from, what the type is, and can now give that to the function, which will now understand how to decode the actual payload or data that's being sent to it. We also have a more structured format where it's of type cloud events plus JSON to in case people want something that's more expressive in that format. I'd say that it depends on who's implementing it and to what level they want to bundle in more cloud event type of attributes into it. I know that from some of my implementation, the binary format is fairly easy to add into existing event streams that are using HTTP. And then that will now be able to play well into the Cloud Event ecosystem. So we have a variety of different deliverables that we put together. These are all available in the GitHub repo. So we have a specification that defines what is all of the metadata that we think is needed for transiting a cloud event. We have different serialization rules such that you can have JSON, MTP, protobuf, etc. event formats and be able to now serialize the event into that format. We also need to be able to transport it. And so we have different binding specifications for these various transports. And then we have a primer that helps people understand what we're trying to accomplish. And then a number of different SDKs for language bindings. The extensions, we anticipate that there will be extensibility needed for special purposes, but we feel that we would prefer not to have extensions wherever possible to make it more interoperable. But we also understand that there will be this need that comes up, and I think there might be a couple that have been defined already. When we're looking at what is the adoption of cloud events, there's several different open source projects that are using cloud events, such as Kata, Dapper, and Knative Eventing is using cloud events natively. And then also in production, Microsoft Azure had built cloud events into their event grid so that you can say, I want a cloud event version of this, and it will now emit cloud event compliant events. SAP, PayPal, IBM via their integrating Knative into their cloud functions have all adopted cloud events in production. There's likely more. I didn't get an exhaustive list here, but I see an uptick on people wanting to use cloud events for this purpose. As I mentioned, we exited the serverless working group with a lot of different ideas about what should come next. And we have brainstormed on a lot of different proposed work streams. What kind of packaging contract do we need, function signature. These are more serverless working group, but they also stretch into cloud events as well. So packaging contract is more serverless working group. Function signatures is the same, but there's also, how do you discover events? What can be delivered from an end point? So we believe that we need a discovery or event registry API to be able to query that and say, what events can you provide for me? And then and then an API for subscription as well, to be able to now say, I want to subscribe to those events. We also think that there's needs for, what is the schema of different cloud events that might be useful as well. So we have a good appetite for, where is cloud events going to go in the future. And the place that we decided to go next was this whole discovery and subscription API direction. And so that's currently being worked on. And then we have a whole bunch of links to, the specs and the various repos. So that was a fast introduction, and I wanted to leave plenty of time for any questions or comments.
Thank you, Mark. Does anybody have any questions for Mark?
Do you think it's interesting to add support for this? Let me rephrase. Do you see the value why I think cloud events would be good to have supported?
Are you talking with respect to adding cloud events into Kubernetes?
So I created an issue to basically, so there is an event API in Kubernetes, but it
Yep.
has a homegrown schematic. So I opened an issue to see if we can make it cloud events compliant so that we basically can reuse cloud event tooling. Yeah, the folks here asked to give an introduction because they are not familiar with it. And I think you did a good job. And I'm now just wondering, yeah, are you convinced?
You know, I had an interesting conversation with someone internal here at VMware. They were challenging me about why would Kubernetes need cloud events? And their argument was, you know, right now you have this declarative API in Kubernetes being able to, you know, why can't you just query etcd for, you know, what is the current state of things, as opposed to having to emit these events that will be out of sync with, you know, what reality is today, or, you know, right now. And my response to that was that it's really intended for different purposes. That you know, what the events are statements of fact. That you know, this is something that has occurred. We want to now transit that to something that may not be in the same Kubernetes domain. You know, and then be able to reason about that external to that. If I had to query etcd all the time, I'd need credentials onto that. I'd need to keep track of everything that's happening on it. Whereas with cloud events, I can now, if there's an event that occurs on my clusters, that can now be transited into, say, you know, filtered, and then into, say, PagerDuty, right? And so you want to be able to act upon, you know, use actions on those events that may be needing to be processed in external systems not connected to that cluster.
Yes, and so I shared the link. That brings me to a similar battle I have with Azure teams who don't see the value of event-driven things or cloud events, because they think they already support it, but it's the data might be the same, but it's the way it is being consumed is sometimes the differentiator.
I want to point out one thing, if that's so. There is, I think, one misunderstanding about naming, because Kubernetes events have totally different semantic what the events that you are describing. So Kubernetes events are free-form, like structured logs that are attached to Kubernetes, some Kubernetes object, or have pointer to Kubernetes object. So they don't have a guarantee of delivery. They have like built-in semantic for squashing events. So if like something is unavailable n times, or 50 times, you don't care. You care about for like the latest state. Basically, you care maybe how many times it happened, not exact time when it happened, or like if there was some event lost in between. So what I wanted to point at is that when you're talking about cloud events, we are talking about introducing a new instrumentation into Kubernetes that would be something different, something different from current Kubernetes events, which are like used for different purpose. So yeah, that's.
I don't fully agree that they are different. With cloud events, you can also still have free form. The difference is that based on the approach that you choose, the free form is part of the data node. If you use the binary approach, it's just the same as it would be today. The only thing that I think would have to change is that there's the introduction of an event type. And frankly, that's the whole reason why I didn't use the current Kubernetes API, is that as a consumer, the only way to process the events is to drink from the fire hose, and you cannot filter events.
Yeah, but event type is that's changing from freeform. I'm not talking about like when freeform, I'm talking about message, like the whole idea about event. Introducing type basically creates like framework and need to track all the types of events that Kubernetes can generate. Currently, any controller can generate any type of events, and no one like.
And regardless of the effort that it would take to introduce that, would you think that would be a better thing to have? Imagine you are new and you want to get started. How in God's name will you know which events are being emitted, what the schema is, and where to start?
I think it's kind of related to like logs, right? Nobody predefines what logs like some application will log. I think in some way the events API is actually an API, and to some degree is actually structured, as Marek said. I feel like I think there are other external integrations already to like write Kubernetes events into Elasticsearch, for example. I believe there's a project by Heptio called Event Router that does this. Correct me if I'm wrong, if this is.
I think that's no longer around.
I don't know that, but I think it feels like it's roughly a similar domain. And so I think I could see the value for something like this. I think if we want to move forward with something like this, the best thing to demonstrate value would be to write such an external integration and show that around. Maybe show it here at the SIG Instrumentation meeting.
You mean on top of the current eventing API, or?
Yeah.
Yeah, but then that's what I was going to do. But then the hard part is there's no good way in knowing who's going to emit what, because there's no governance now. Everybody's just sending whatever they think is best, and it's hard to integrate.
It sounds like you need to introduce some formalism around.
Yes.
How would you be able to specify the type of an event, and then be able to have a better definition as to what that event schema would look like? Yeah. But having a free-form event, which I think you said that it looks more like log data, doesn't seem formal enough for the type of system that Kubernetes is built around.
I think this is kind of what Marek was alluding to, that it seems like maybe the only thing that cloud events and Kubernetes events have in common is the name event, and really the philosophy behind them are just fundamentally different.
Yeah. So one thing, one major concern is that if Kubernetes events don't have guarantee of delivery, which I think is crucial in the systems that you're trying to build. And
no. Events are best effort from my perspective.
Okay. So when someone designs like pipelines with brokers and I know some triggers, it's still best effort. Yeah. So you're still building best effort.
Mm-hmm.
Okay. So that's good to know, because I didn't get that from the presentation that you.
At least that's my opinion. But
we're not prescriptive on that.
Yeah.
Right. There may be some usage of it that does require that level of delivery, but we are not prescriptive about what that is. We're looking at how do we transit it, not how do you guarantee delivery of it.
Yes. And I think even though there might not be enough overlap today, I would seriously consider this to be the next evolution of the current approach. There has to be more infrastructure is a very, very big word, but as consumers and certainly not Kubernetes experts, having a way to filter events is super important.
Yeah, I'm definitely not disagreeing. I feel like maybe the events as we have them are too raw of a thing to build cloud events around. It seems like maybe maybe cloud events is more suitable for like maybe transforming alerts from Prometheus, let's say, into a cloud event and ingest that into some other system, or an alert that's produced by Elasticsearch based on the unstructured events that we have today.
That's true, but it can also be just as simple as, hey, this deployment was created. Hey, this HPA scaled up, HPA scaled down, all of these kind of things. And I'm pretty sure it's already possible, but it's not really easy. And regardless of that, there's a lot of tooling around cloud events already and a lot of integration. So yeah, why not just make it compliant?
Yeah, I think like our discussion here showed that like just make it compliant isn't really the difficulty with Kubernetes here. It's more the data that we have, right? I don't think people are necessarily saying no to having this kind of metadata around the data, but if the data is not in a form that would be very useful to integrate with cloud events, then that's the thing that we would need to fix first, right? And if that's a fundamental thing that Kubernetes doesn't want to change, and frankly, that's something that we would also need to discuss with Kubernetes API machinery, because we're primarily in charge of instrumentation itself, but like API kind of things is definitely Kubernetes API machinery territory. Yeah.
Okay.
So yeah, my recommendation would be to, even if it's not perfect, build some sort of external integration to show the value of this, and then show these kinds of use cases. And I think if we can have something very concrete, then there could be a possibility where we do something like this. Obviously, that all the things that I said about API machinery and all of those things, it's not just this group that can decide these kinds of things. But I think that would be a way how you could convince the Kubernetes project as a whole to do that.
Yeah, so there is some intermediate steps that you could take, which is, say you're attaching to functions as a service. We did this around vSphere events, which are not cloud events. But we subscribe to the vSphere eventing. I have those transited into an event driver that then transformed the vSphere event into a cloud event and then forwarded it on. That same approach can be used for Kubernetes for the events that you know about.
Yeah, exactly.
And then you could prove out interoperability with other systems, the usefulness of it. But I would like to see, again, how could we build cloud events directly into Kubernetes as a first-class citizen event stream?
Yeah, yeah. I think what you said is a good first step, and there are you can extrapolate some sort of list of events that are roughly well known and produce these kinds of things. And that's kind of what I was saying. That's how we could have someone could create a proof of concept for this. And if the Kubernetes project based on that decides this could be of value, then we can have another discussion around that. But having said that, we are out of time, and I don't want to keep people from attending to their other schedules. So thanks everyone for joining today's Kubernetes SIG Instrumentation meeting, and have a wonderful local time. Bye-bye.
Thank you for considering. Bye.